Hey guys, this is for those of you that can't attend the Google Meets live CP Chem lecture. So I'm going to go ahead and do just a mini set of notes related to mole ratios in chemical equations. So kind of the premise here is that a chemical equation represents an ideal reaction. We've been talking about equations since the start of the school year. And you guys know that in an ideal reaction, particles are conserved. And so when we talk about number of particles or moles, we are relating coefficients in our balanced chemical equation. So I'm going to give you kind of a generic version of this today, and then we'll go through some actual chemical equations, balancing and then describing the relationship between the reactants or amount of reactants and the amount of products. So let's look at this generic equation here. So in this equation, what we're going to do is we're going to look at the relationship between car frames or the body of a car, the number of wheels on a car, and the number of cars that like General Motors or Ford or another manufacturer can produce. So in this relationship, we're going to first go ahead and balance our chemical equation. So for every one car body or frame, we need 4 wheels, obviously, to yield 1 car. So if we're writing or representing this equation in words, we would just say for every 1 car body, and 4 wheels, we can make 1 car. And by we, I mean the car manufacturer, right? So then we can go ahead, and if we're going to change the amount of cars that we want to produce, then all we have to do is look at these ratios of coefficients to determine how many car bodies or wheels we would need. So let's say our given is 16 car bodies. And we want to know exactly how many wheels and how many cars we would need and then make as a result of that given. So I'm going to go ahead and start with the given. And then I'm going to use ratios to compare the given to the number of wheels or the number of cars. So we know, according to our balanced chemical equation, that for every 1 car body, we need 4 wheels. So I'm going to go ahead and write that as a ratio, where in this case, the 4 wheels are the numerator. Close the door, please. So what I'm going to do is I'm going to then go ahead and multiply 16 car bodies times 4 wheels and then divide that by 1 car body. And what you'll see is that the car bodies cancel and you are left with 64 wheels, right? So you would need 64 wheels for 16 car bodies to yield a certain number of cars. So we're going to do the same thing to determine how many cars 16 car bodies would make. So for every 1 car body, and this one is pretty easy, we know that we make 1 car. So in that equation, what's canceling, obviously, are the car bodies. And if we start with 16 of those, we have an equal number of cars produced because it's a 1-to-1 ratio. So that's pretty easy. And that would be kind of analogous to like number of particles in a chemical equation. So we're either going to relate number of particles in a chemical equation, or we're going to relate coefficients as number of moles. In either case, it's a counting number, right? So let's say that in this next example, we have 18 moles of cars that are produced. And we want to determine how many moles of car bodies and how many moles of wheels we would need. Again, a mole is just a counting number that represents a certain amount of particles. So let's go ahead and we're going to start with our given. So I know for every 18 moles of cars, that for every one car, there are, there is one car body required. So here, I'm just multiplying my ratio. If I have 18 moles of cars produced, and the ratio is 1 to 1, then I know that I would need 18 moles of car bodies to make that many cars. I'm sorry, I'm running out of room, but you get the idea. If we did the same thing, and here we were calculating for the number of wheels necessary, in that example, we would start with 18 moles of cars. And the ratio here would be for every 1 mole of car, you need 4 wheels. So there you're multiplying by a ratio of 4 over 1, which gives us 72 moles of wheels. Hopefully this is making sense. It's hard to, get a gauge on that when you guys are learning remotely. But what it comes down to is basically these ratios can be used to compare numbers of particles or number of moles for your reactants and products in a chemical equation. So let's look at a second example, and I'll just start this one. I'm going to go ahead and erase part of this so you can see. In this second example, we're using a chemical equation, and we're going to go ahead and balance that chemical equation first. So here we've got nitrogen gas plus hydrogen gas yields nitrogen trihydride. So in this equation, we know that we need to balance numbers of particles. So for every 2 moles of nitrogen trihydride, we've got 1 molecule of nitrogen plus 3 molecules of hydrogen, and that's a balanced chemical equation, right? So our relationship would be for every 1 mole of nitrogen and 3 moles of hydrogen, there are 2 moles of NH3, which is ammonia, produced. Okay, so that said, if I were given 0.2 moles of ammonia and asked to convert from moles of ammonia back to moles of nitrogen or moles of hydrogen, I would need to use some ratios. So we're going to go ahead and start again with what's given, which is your 0.2 moles of ammonia. And then we're going to multiply it by a mole ratio, which compares our coefficients. So in the balanced chemical equation, for every 2 moles of ammonia, there is 1 mole of nitrogen, right, in the reactants. And so we go ahead and we cancel out our moles of ammonia, and we divide 0.2 by 2, and we get 0.1 moles of nitrogen. And we're going to do the same thing, start with the same given for hydrogen. So we have our 0.2 moles of NH3 or ammonia as our given. And we're going to convert from moles of ammonia to moles of hydrogen, which is now a 3-to-2 ratio based on the coefficients in that balanced chemical equation. So if you multiply 0.2 by 3 and then divide by 2, you get 0.3 moles of hydrogen. Okay, I'm going to do one more and then I'm going to let you guys finish this up for homework. Let's say instead of 0.2 moles of ammonia, we are given 8 moles of nitrogen and asked to convert to moles of hydrogen and then moles of ammonia. So we're going to start with 8 moles of nitrogen. I know for every 1 mole of nitrogen, I need 3 moles of hydrogen gas. So here we multiply 8 by 3 and then divide by 1, which tells us that you would need 24 moles of hydrogen if given 8 moles of nitrogen. Again, in this equation, the moles of nitrogen cancel. We're going to do this last one, and then you're on your own. So in this last one, we are converting 8 moles of ammonia. Sorry, no, 8 moles of nitrogen. My bad. I got distracted. Livy just walked in. 8 moles of nitrogen to moles of ammonia. And so here the ratio is for every 1 mole of nitrogen. Sorry, I'm running out of room. You are producing 2 moles of NH3. Again, nitrogen cancels. You're left with moles of NH3. And the answer here would be 16 moles of NH3. Again, it's kind of a little bit hairy in there. Sorry, it got real tight. So your final answer would be for every 8 moles of nitrogen and 24 moles of hydrogen, you would yield 16 moles of ammonia. Final answer. Okay. So go ahead. I want you guys to finish up this worksheet for homework. And I think you need to check and correct it then on Thursday later this week. So let me know if you have any questions. Again, you guys, I'm available for office hours from 1 to 2 daily. So if you're struggling, please reach out either via email or, you can always jump into office hours and ask questions. So hope everyone is happy, healthy, and staying safe at home. The weather will eventually lift and it'll be spring and beautiful outside and sunny and all good things. So miss you. Talk to you later. Bye.